Swanky Swifters, this is Prof G, and we're going to finish up our Dungeon Dice app by working with a fairly advanced concept. We're going to use SwiftUI preference keys to pass a value up through our view hierarchy from a child view to a parent view. And this will get around to quirk with the geometry reader, where it hogs up all the space available to it. Even though this is a more advanced topic, I know you're up for the big learning. Giddy up! In our last lesson, we began refactoring our Dungeon Dice app by breaking out the smaller, less complex views into an extension and putting these views inside of computed properties. Now feel free to go back to the prior lesson if you haven't seen that yet, but now we're going to tackle the code layout for our buttons, and that's more complex. That's the one with the lazy V-grid and the H-stack. So we're going to start by creating a computed property for this code, but we'll see that extracting this code and putting it into SubView might be a better choice. We're also going to run into a really tricky problem using GeometryReader with SubViews. This is a problem that flummoxes lots of developers when they encounter this for the first time, but we'll point out the issue and we'll show how you can solve it with preference keys. So let's dive in. Now down in the content view extension, let's create a computed property for our button layout code, the lazy V-grid and lazy H-stack code, and we'll call this simply button layout view, lower camel case, because this is a variable, a computed property, and we'll code this with private var button layout view, some view, capital V, open and close curlies. Then let's start by cutting out just the lazy V-grid code. So that's from the curly just before the H-stack through the lazy V-grid setup line, Command X, then back down in the computed property we just set up, paste this in. And we won't see anything in the preview until we remember to put the computed property in the V-stack, so we'll head back up there, and we'll enter button layout view, where we just cut out the lazy V-grid code. And now we see all of our buttons in the preview. Try it out. Works great. So far, so good. Now, since this H-stack works with the lazy V-grid to lay out all of our buttons, I want to cut out this H-stack code and also paste that down into the same computed property. So make sure you've highlighted just the H-stack code. You don't want to take this extra curly brace at the end. Command X. I'll head down into the variable that I just created. That's the button layout view. And I'll paste this in just before the closing curly of the button layout view. So you should have two closing curlies before your flush left. But when I do that, I get an error. It says function declares an opaque return type. That's not a very helpful error. But let's put on our deerstalker hats and see if we can Sherlock out the reason why we're getting this error. And here's a clue. We see a yellow warning down here that says the result of the H-stack is unused. Why would it say this when we encounter the second view in this computed property? Oh yeah, just like the body computed property, we can only have one top-level view, but we have two here. The lazy V-grid and the H-stack are at the same level, but we know how to fix this the same way we would in the body property. We can just embed both views in this case a V-stack, and that V-stack will act as the single top-level view. Let's try this out. We'll command-click on lazy V-grid, we'll select embed in V-stack, then we'll cut out this H-stack code and paste it inside the V-stack. Now look at this, I can code fold the lazy V-grid and the H-stack, see they're both embedded inside this V-stack. We can try out our code, and we can see it's working great. Now let's take a look at the top of our code. We can see that there's a lot of stuff in here that only applies to the button layout view. The enum only works with the buttons, same thing for these variables here. Now it is possible to put the enum and additional variables inside of our computed property. We'd have to have a return statement in front of the V-stack, but we also want to add the function that we have in here because that also only applies to the button layout code, and adding a function into our variable isn't something we want to try. So if you see that a computed property for a view is getting sufficiently complex, usually if the code requires functions or if there are lots of additional variables or custom data structures, and that's definitely the case here, then it's likely going to be better to put the view in an extracted subview rather than to try to do it in a computed property variable. So let's do this. I'm going to code fold my entire button layout view. I'm going to cut this out with a Command X. Then below the extension, but before the preview provider, I'm going to create a new subview. Remember how we do this? Struct. We've got to give this a name. We'll call it button layout upper camel case since a view is a type. Then view with a capital V, open and close curlies, and we'll paste in the computed property code that we just cut out. Now it's between the curlies. Now I'm going to remove the private keyword before the var declaration, and I need to change the first variable here. I need to name it body, since all views need to start with a body variable, that body computed property. Then we see a bunch of errors in here. First, we should head back toward the top of the content preview code, and where we had previously referred to the variable button layout view, Let's delete this and now enter button layout upper camel case, and we need to include open and close parentheses after it. This creates a new instance or a new copy of the view using the code in the subview we created like it's some sort of blueprint. The open and close parens are sort of like saying, go to the button layout view factory and create me a new one. Now as we scroll back down to our new view and look at these errors, we see little red underlines underneath a bunch of variable names, button with spacing, also the dice enum. And if you look more closely at the code, we'll see that those values are only used inside of this new subview. So we can cut them out of the declaration above and paste them inside of our new subview. Let's start with the enum. So highlight the entire enum, including its function, cut it out with the Command X, then I'll jump bar down to button layout. Remember, our button layout subview is also a struct. That's what the S to the left of button layout in the jump bar means. Then below the struct definition line and above the body property declaration, I'm going to paste in the enum, and we've still got a bunch of other errors. But if we head to the top, we can see that all of these variables and constants are only used in the subview or the function, except for result message, which is also used in a text view and the context view. So why don't we highlight these three constants and the button leftover state variable, cut them out, head down to our subview again, and paste these in just after the enum and before the body property. And we see that the only remaining error now that's showing up is the one related to the result message state variable. That error shows up in two places in this view. Now we need result message in both the content view and in our button layout subview. So what we want to do is we want to pass the value result message, which is in the state variable in our content view, to our subview. And if we make a change in the subview, this should trigger a redraw of all of the views that use result message. Well, there is a special way we can do this. We declare, but we won't initialize a variable result message inside of our button layout view. Now I'm going to do this right after the state variable buttons left over and before my three constants, and we're going to precede this with the property wrapper @binding. So this is what we enter. @binding with a capital B, var, result message, :string. So we've declared this variable, but we haven't initialized it. And that's because the value that we're going to put inside of this is going to come from the content view when we call the button layout view. This is going to allow us to pass the state variable into this new view, and the binding part here says, hey, if we make any changes while we're inside of this view, we're going to trigger a redraw of any of the views that have result message in it. Now we get an error up here where we call button layout view. And the reason for that is to create a button layout view. We don't create it with no variables in the two open and close parentheses, but now we need to pass in a result message, that binding value that we just created. So I'm going to backspace over the two parentheses, and if I type button layout open parens again, we can see now code completion says, hey, you need a result message in here. I'll press return to accept this, and I'll enter result message. Now we're still getting an error in here, but if we click the red error circle, this says that we need to add a $sign whenever we pass a value into another value that's a binding variable. Oh, cool. Very similar to how we work with two-way bindings when we learned about these in our You Are Awesome app. And we're pretty much doing the same thing here. We're passing a value into the button layout view, and we might be making changes into that view that need to be passed out because they impact the sending view. Cool. So click Fix, it'll add a $sign in front of the result message value, and the error goes away. Now we're still getting errors. These are all related to this function, but since the function arranges grid items, that's what happens in the button layout subview, no longer in the content view. So we should highlight this function, cut it out with the Command X, and paste it in before the closing curly in the button layout subview. And if you need help finding that spot, you can just code fold in the V stack in your button layout subview. It's just before this closing curly here. And the preview still says that we've got some errors. Let's scroll up, and oh yeah, it looks like onChange and onAppear can't find what they need. Oh yeah, they're calling arrange grid items. That's the function that we just moved down into our button layout view. So why don't we highlight these two modifiers, onChange and onAppear, cut them out with a Command X, then we'll head back down to our button layout, and right underneath the V stack inside the body property, we'll paste those in. And oh man, we're getting more errors on these lines with the geo variable in them. And oh yeah, that's because geo was defined up here in this geometry reader, and we don't have access to this in our extension code. So now in order to illustrate some common errors and some genuine weirdness when using the geometry reader in subviews, I'm going to go through a few things that new SwiftUI developers and even some seasoned developers might think that they can do. And this is going to raise issues that'll be important when you build future apps, but we'll show you how we can solve all these problems. Now, one thing you might think is, can I just move the geometry reader around down to the V stack inside the button layout view and use it there? Well, let's try it. We're going to delete the geometry reader from the content view. Make sure you also delete a close and curly down here. And whenever I delete a closure like this, I always do a Command-A, Control-I to make sure that I fix my indents. Then above the VStack in the button layout view, we're going to create a new geometry reader by typing in geometry reader, selecting the option with content, press return to get the trailing closure. Now the thing that provides you with data is of type GeometryProxy, and we've been calling this lowercase geo, so that's a good name. We'll continue to do that. And now we'll cut out our VStack. I'll code fold the VStack, and you also want to make sure that you get the onAppear and onChange modifier. Those are part of the VStack code. And we'll paste that in between the parens of the geometry reader, give the preview a second to catch up and run this code, and yak! We can see some really weird resizing, which we'll want to address. So it's not initially clear what happened here. You might think that you can fix this by adding a spacer inside of the VStack up top, but that really doesn't fix things because look, it just pushed the result message text up to the top where the buttons once were. So it looks like this button layout view is huge. Why is it so big? Well, first I'll delete the spacer. That doesn't do anything related to the large size of this button layout view. And next, let's get a sense of what's going on by using some border modifier. So I'm going to first add a border modifier below the onAppear modifier. Now, since onAppear is part of the VStack, this is going to put a border around the VStack, and I'm going to set that border color to .red. And we see that there's a red border just around the button, so that's our VStack. But if I code fold the geometry reader and add a border modifier below that, this time making it black, look at that. What's actually happening here is that the geometry reader is taking up as much space as it can. It doesn't matter that the VStack just wants the space around the buttons, the geometry reader is going to hog up everything it can get. That's how geometry readers behave. They'll push out as far as they can go. But what we want to do is to restrict the geometry reader so it only takes up the space of the VStack in this view. Now we'll make a few more goofs along the way in trying to solve this, but then we're going to demonstrate the real way to deal with the geometry readers in SubViews by using preference keys. Now one thing that gets us closer to what we want is by using an overlay modifier on the VStack. So just below our red border, enter .overlay. Now you might remember that we used an overlay modifier to draw a rounded rectangle around a text field in an earlier lesson, so select the overlay with a content parameter. Code completion says this modifier layers any view we specify in front of the view. So if it's in front of the view, that should make the overlay the same size as the VStack. So let's put the geometry reader inside this overlay and hopefully it'll get the right size. So we'll select this, press return, we'll return again to get the trailing closure. Inside the trailing closure, let's create a new geometry reader and give the GeometryProxy the name Geo like we always do. We'll delete the old geometry reader, and I'll also delete the closing curly and the black border that was around it. And we get a bunch of errors above this where I was referring to the geo variable that was part of the geometry reader. Dang! We now define geo in the overlay modifier, but that's below the VStack. It's not in the scope of the VStack, so it doesn't have access to it. So, well, we can try something that might seem like it'll work. We can create a new state property up here, @state private var, and why don't we call this device width, lower camel case, and we'll say colon and declare this as CG float. Remember, that's the type we need to measure things like width and height. And then maybe we can initialize this inside the geometry reader's closure down here, setting device width equal to geo.size.width, and we can replace geo.size.width in the onChange with device width, and in the two calls to arrange grid items. Come on, work code. And no, we get this error here with the type parentheses cannot conform to view. This is a really cryptic error, but it's the same thing that we got when we tried to print from within a view. This just doesn't work. We can't use assignments inside of the parentheses of this closure here. So I'm going to comment this device width equals geosize width line with a command slash. Then I'll head to the top of this new view, and I'm going to delete the device with state variable that didn't work. And instead, I'm going to show you the technique we need to use when using a geometry reader in a subview. But this technique is also useful whenever you want to pass a value up from a subview back up into its parent view. And if we consider the geometry reader inside the overlay modifier a subview, and it is, then we need to pass this up to the parent view, which is the VStack, so that it can be used inside of the function calls that are part of the VStack. So here's how we set things up. Now our goal is usually to minimize the amount of code that we write, and we're about to introduce more code, so an argument can be made that we're complicating things, but this bit about wanting to find a dimension of a child view and then pass it back up to the parent view is something that developers frequently need to do, so it really is worth exploring here. And it's unfortunate that this passing values up the view hierarchy requires so much code, and it's not very friendly code to the new or even intermediate developer. But once you get this done, the steps will be fairly repeatable. And although we'll set this up to pass a CG float value, that's going to be the width of our device, up to the parent view, you can also change the type that you're passing. So you can send up strings, a full geometry reader, or really any other type if you'd like. So we're going to use a special SwiftUI technique that allows us to pass certain values from child back to parent. Now this technique is called PreferenceKeys. And to implement PreferenceKeys in SwiftUI, we need to do three things. First, we need to create a struct to hold our preference key, and we need to conform to the preference key protocol. Now this just means that our struct is going to follow specific rules for using a preference key that have already been set up in SwiftUI. So this is going to tell us that we need to create and initialize a default value, and we need to include a special function named reduce. Now fortunately, we can get Xcode's fix to write most of this code for us. We'll just need to make a couple of modifications. Then we'll need to add a .preference modifier in the child view and use this to set up our preference key value. Now in this case, we're going to do this to get our device width, and we're going to do this inside of the overlay underneath where we have our geometry reader. We'll have to add one more thing inside of the geometry reader so we can get the geometry of that thing inside of the overlay. We'll just put a color in there. You'll see how we do that in just a bit. Then when we want to access our preference key value, for this it's going to be our device width. And remember, we need to do that further up the hierarchy. So in the parent area, in one of the modifiers underneath the VStack, we're going to use an onPreferenceChange modifier. So that's going to allow us to get our preference key value, which is going to be our device width. And when we do this, onPreferenceChange is also going to allow us to get rid of the onAppear and the onChange modifiers we were using earlier. So let's start with this first step here where we create our struct conforming to the preference key protocol. Now, when we referred to protocol before, we said that protocols were sort of like setting up the rules to engage or to use a particular technique. So we're going to start out here right underneath the enum by creating a structure. We're going to say struct, and we're going to give this a name. We're going to call it device with preference key in upper camel case. Then we'll say colon, and we'll say preference key with a capital P, capital K in there. Now that's the protocol. So when we put this in and follow it by curlies, this is going to indicate to SwiftUI, hey, we want to make sure we're following the rules to be able to work with preference keys. Those rules are defined behind the scenes. And just so you know, if you option click on preference key, Xcode will tell us, yep, this is a protocol. Now we don't yet conform to the rules of the protocol, so we're going to get an error. So if we click on this little error circle that we get here, Xcode offers to add the protocol stubs or the things that we need to follow those rules. So let's do that. We'll click on the first fix here, and this first bit asks for a type alias. So this essentially is, what is the type that we're going to be using in here? Now we want to pass a CG float up, so I'm going to set the type alias to be CG float. Now we get another error in here, and now that the protocol knows what the type is, it's going to offer to add two more stubs. So let's go ahead and click on the fix, and we see that Xcode adds two more things to this struct. Now the reason why Xcode didn't do all of this fix at once is because first we needed to say that the type alias was CG float, so it knew it could add CG float in the static var up here and in the function. So again, this looks a little gnarly, but let Xcode do the work and just click on the fixes. Now this gives us a default value and a reduce function. The default value has an error in here. It wants an initializer, and we're just going to initialize this to 0, so I'll set it to equal 0. Now what's this reduce function all about? Again, gnarly code. We don't see this very often. The in-out here means that the parameter that we're passing in isn't the normal let constant, but we're actually going to be able to make changes to that, so treat it like a variable. Now the next value is a function that's going to return whatever new value we want to use. So you could do things like consolidate multiple values in here, but all we want to do here is to replace the value with whatever updated value we get. And frankly, in most cases, that's what you're going to want to do. So we're just going to say value equals, and then it's going to be lower camel case next value with the open and close parens. Now there's one more thing to know about the code here. See the word static in here? This means that we don't need to create an instance of this variable or declare a variable of this struct type in order to access the variable and the function inside of it. So static values can be accessed just by referring to the struct type. In upper camel case, normally what we need to do is to create a variable from the struct blueprint, so something in lower camel case. Not so here, since we add a static variable keyword here. This also means that there's only one default value that we use. That's a single one inside a device with preference key. Again, ugly code, but this allows the preference key value to be updated. So if you ever need to go through this, these steps can pretty much be followed like a recipe. Just make sure that you adopt the preference key protocol, let Xcode do the work for you. Now that we've got this struct set up, we're going to get the value that we're going to use in our preference key, and then we're going to set up a special modifier to pay attention to whether the preference key has changed, and if so, we're going to tell it to do something. Now down here in the Geometry Reader, in the overlay, remember this is the child view that we need to get a value from, we first need to add one more thing in here. Now the Geometry Reader is inside an overlay, and the overlay is on top of the VStack. It's a modifier of the VStack, so putting the Geometry Reader inside the overlay of the VStack will ensure that the Geometry Reader doesn't expand beyond the VStack, which is what it was doing before. Geometry Readers are those space hogs. They take up as much area as they can. So the overlay is going to restrict this to be just the size of the VStack. But we need to put something inside the Geometry Reader so the Geometry Reader has something that it can use to get the geometry of. It can't read the geometry of stuff above it. And to do this, we're going to add a simple color that's clear. That's just going to create a view that's entirely see-through, but since the overlay restricts it in size to the same size as the VStack, we're going to get the size of the VStack. So the code inside the Geometry Reader's curlies here is just capital C color dot clear. Then, underneath the clear color, this is where we get to the second step of working with preference keys, we use the preference modifier to set the preference key value. We don't simply set it using an equal sign, we need to use this modifier. So we'll enter .preference, select this first option here with the key and the value, press return. Now our key is the preference struct that we created. See it up here? So we're going to enter the struct's name, which is device with preference key, upper camel case, but we also need to include a .self after it. And if you had forgotten that, Xcode will give you an error and offer you a fix. Then tab over to value. What's the value we're putting in here? That's just going to be geo.size.width, the width of the color, which is the overlay that's overlaying the VStack, so we're going to get the width of the VStack, but since we're inside the overlay, getting the geometry of the color that's in the overlay, we're not going to let the Geometry Reader expand the height in the hoggy way it was doing before. And now for the third and final part of setting up preference keys, we need to add a new method that observes when a preference change was made in the child, and we put in a code in there that will trigger an action that we should perform when the change in the child occurs. So to do this, after the .overlay closing curly, start to enter on preference. Select the one with the change option. There's only one in here. Press return. Now the K is a little cryptic, but this just wants us to name the struct that we created earlier. For us, that's device with preference key, upper camel case. And I see as I'm putting the voiceover in here, I forgot the .self in here. We always use that at the end of any types that we create in our code, but Xcode is going to remind me later on with an error and it'll offer to fix this. So I'm going to tab over and I'm going to press return to get the closure. Now you could call the value in here anything you want, but I'm going to call it device with lower camel case. And once we get that, what do? Well, the same thing we did with the onChange and the onAppear. We want to call the arrange grid items function. So I'm just going to copy that from up here. I'm going to paste it in between the curlies of onPreferenceChange. And since we're going to get the device width from the child whenever the width changes, whenever the code first starts or when the device changes from portrait to landscape or back, we can actually go ahead and delete the onAppear and onChange modifier up top. We don't need those. And here's the error that I referred to that I would get. I forgot to add the .self after passing in device preference key, but if I click on the error circle, Xcode with the last fix here offers to include the .self. I'll click that, it's fixed. Awesomeness. Now Xcode takes a while for preview to kick in. I'm going to click live play to goose it along. And hey, the buttons fall down to the bottom where we want them. It looks like we've tamed the Geometry Reader. Let's click on the buttons to make sure that our result message is back in the middle of the screen. It is. Working great. Excellent. So this was a lot of work, but hopefully we described this advanced concept in a way that was understandable, and even more importantly, hopefully we've offered you a recipe that you can follow when you need to do this again in future apps. So now that things are working properly, I'm going to get rid of the red border underneath the VStack that I used for diagnosis, and this is looking good. So now that we have this nice working subview named button layout, I'm going to put this whole subview in its own file so that my code is more modular and I don't have the button layout clogging up the bottom of my content view. So I'm going to right click on content view in the project navigator, select new file, select SwiftUI view, click next. The convention here is to give the file the same name as the view that's inside of it. I should have entered button layout upper camel case, instead I put in button layout view. Shame on me. There's no problem, my code is just going to work, but if your file has the exact same name as the view struct that's inside of it, it's just going to make it easier to find that view when you're looking in the project navigator. Click create. I'll head back to content view, code fold my button layout view so I'm sure I'm selecting the whole view. I'm going to highlight this, cut it out with the command X, return to my button layout file. I'm going to paste this over the generic view that Xcode creates. This is almost looking good, but the problem I have here is that pesky preview provider. I hate those things. I hope Xcode makes these easier to use in future versions. Now the issue here is that we need to pass in a result message because we've got that value declared but not initialized at the top of this code. We're actually passing that in from the content view, and we can actually see this if we highlight the button layout. It says button layout view in here. I should have said button layout when I named my file. Delete it, then retype it, and I can see now that the button layout requires the result message parameter, so I'll press return. That parameter is entered in here, and the prompt that I get here in the preview provider isn't going to be very helpful. It mentions a binding in here, so you might be tempted to enter $result message as a variable. That's not going to work. So what we need to do is we need to pass in a generic constant value, and we can't even enter an empty string in here. We have to use .constant. This gives us parentheses, and then in between the parentheses, we pass in an empty string. Really weird. Just remember to use this whenever you want to pass in a constant to get your preview provider to work. Now, it's going to take a second for the preview to catch up, but we can see that the buttons are laid out just for this view, so we're not running the entire app for this file. That's why all we're seeing are the buttons laid out in the center, but this is correct, and this is what we expect to see here. Cool. Now, if we head back to Content View, we see the preview starts running from this file, so we see the full app running in our live preview. This works great. Now, we're already passing the binding result message value with a $sign here, which is required when we work with SubViews, so don't forget this, but we did this early on in our lesson, so we didn't have to do it again. Nice work. And we can say how versatile our code is, because if we say, go back to our button layout file and change our enum by adding another case, say a 50-sided dice, which doesn't really exist, look at this. The new button lays out perfectly where it should. We can head back to the content view. We see it shows up here. And if we click play and run in the simulator, and I'm going to do this on an iPad mini so we can see how things work. Hammer time, no errors. My iPad mini is upside down from an earlier simulation, but if I change orientations, the buttons are laying out perfectly, working great. So Swifter, exceptional work. I've added an app icon and a launch screen in the Dungeon Dice files folder in bit.ly/prof-g-SwiftUI files, all lowercase. Feel free to add that using the techniques that we learned in our first app, but we're finally done with Dungeon Dice. Now this was a simple app, but we deliberately built this with some more advanced techniques to see how we could work with a bunch of new concepts in SwiftUI. For each, lazy stacks and grids, centering the last row or column for a lazy V-grid or a lazy H-grid. We extracted views using variables in an extension, and we separated out subviews and put one of those in a separate file, and we learned how to use the preference keys to work around GeometryReader's hoggy quirk where it wants to take up as much space as possible. And I think it's best to introduce these concepts on a simpler app so that we don't overwhelm you with so many concepts when we build even more complex apps, but we're going to see many of these techniques in apps to come. Keep hacking Swifter. There are more apps and more big learning right around the corner. And remember, take a screenshot or video of any of the apps you're building as part of these lessons, CC me on Twitter at Gallagher with the hashtag BuiltWithProfG, and you might win the weekly drawing for a free laptop sticker. Ultra cool. I'll mail that anywhere in the world if you win, no charge. Stay Swifty, my friends.